Hello students, welcome to Yupp Master. So in our last class we have seen how to solve a problem from non-inertial frame. So how to add pseudo force and how to solve the problem, this we have seen in the last class. So today we will take some more problem and I'll try to clear your concept related to the pseudo force. So let's start. Look at this one. So there is a wire in parabolic shape and it is being dragged with acceleration a0 towards left, okay, and question is what should be the x coordinate of the bead through which wire passes if bead is stationary with respect to wire. If bead is at a particular position with respect to the wire, then what should be the value of acceleration a0. So as I already told you, you can observe the motion of bead with respect to ground, or you can also observe the motion of bead with respect to wire frame. So when you are observing motion of bead with respect to ground frame, then you will observe that bead is having acceleration in this direction a0. So I'll draw all the forces on the bead, and along x direction I'll apply Newton's second law, F is equal to ma0, and y direction, as bead is not moving with respect to the wire, it will be with respect to wire, it will be at fixed location. So bead keep moving in horizontal direction. So y direction I'll apply Newton's first law, x direction I apply Newton's second law. Okay, as here we are discussing how to solve problem from non-inertial frame, instead of taking this observer, I'll take observer here. So if observer is here, what he is going to observe? This observer. So he will observe that bead is at rest. So for this observer, bead is not moving, it will be stationary, right? And I want to find out the x coordinate. I can also ask what should be the height of the bead from this point, origin 0, 0. So this bottommost point, I am taking origin, and from origin at what x distance it will be at equilibrium, right? Now as our frame is non-inertial, first thing I am going to do is adding pseudo force, mass of the bead, acceleration of the frame, then there will be normal reaction. So here I will draw tangent and perpendicular to that there will be normal. So on bead normal will be like this. So for time being let's remove this x, and there will be field force mg acting in downward direction. So two real forces, normal reaction coming from the wire on the bead, and another field force mg acting in downward direction. Along with that, as our frame is non-inertial, I'll add pseudo force, mass of the object, acceleration of the frame, direction opposite, right? So this is, or these are the forces observed by observer. Now if I draw tangent at this particular point, let this angle be theta, and for this observer bead is at rest. So for this observer you can resolve all the forces along y direction, x direction, equate that, or with respect to this observer along the tangent and perpendicular to tangent you can resolve all the forces. In all the direction he will apply Newton's first law because he is not going to observe any motion. Okay. So if this angle is theta, this is normal, right? With vertical this angle will be theta, with vertical this angle is theta and this angle is theta. If this one is theta, if this one is theta, this is also theta. So all the angles I know, I'll resolve all the forces along and perpendicular, right? So look at mg. Mg will have two components, one in this direction, that is mg cos theta, and another in this direction, that is mg sin theta. So mg, I resolve the component, I'll remove mg. Okay, now mg over. Then I can see this ma naught will have two components, along the tangent and perpendicular to the tangent. Let's resolve ma naught. So ma naught cos theta and ma naught sin theta. So ma naught also I resolved, I will remove ma naught. So this is what is observed by this observer, and he is observing that bead is at rest. So what he will write, along tangent forces must get balanced if bead is stationary with respect to this wire. So along tangent he will write ma naught cos theta minus mg sin theta is equal to 0. Sin theta, Newton's first law, is equal to 0. So if you simplify from here, we have tan theta is equal to a naught by g. Tan theta is equal to a naught by g. Now tan theta is slope of tangent to the curve. So this is the curve whose equation is given by y is equal to x k x square. If I differentiate this equation, slope which is tan theta can also be calculated by dy by dx. I can use differentiation here. So if I differentiate that relation, I will get dy by dx, differentiation of x square is 2x. So this I am getting 2kx, and from here I have value of tan theta which I can place in this equation. So tan theta, which is a naught by g, is 2kx. That means x coordinate of the point where bead will be stationary with respect to the wire will be a naught divided by 2 kg, k into g. So this is x coordinate. If I ask what is the y coordinate, so I got this distance, x coordinate. If I ask what is the height or what is the y coordinate, I can substitute this value over here. If I substitute x over here, then I will get corresponding value of y. Simple. So I consider non-inertial frame, as I want to observe motion with respect to non-inertial frame. The only thing I need to do is just add extra term which we call pseudo. After adding pseudo, what this observer observes, accordingly you need to write equation. As observer is observing no motion, we will apply Newton's first law. So I apply Newton's first law along tangent. So it is stationary in this direction. In this question you need not to write equation in this direction. If you are interested in writing the equation, anyway that is not needed, but if you want to write the equation, then you will write n minus ma naught sin theta minus mg cos theta is equal to 0. So this equation along tangent and this equation along normal. Out of that From this equation I have tan theta which is required here. I substitute the value and I will get the answer. So I hope this question is clear. Let us see next one. See, so we have got one wedge and this angle is 53, it is given. Same we have here 53 degree. Mass of this block is m1 and mass of this block is m2. Now go through the question. The wedge undergoes constant acceleration. It is given 5 meter per second squared. So this wedge is accelerating in this direction with 5 meter per second square. Question is what should be the ratio of these masses of block, so that they won't slip with respect to wedge. So they won't slip with respect to wedge. So person is standing on the ground, what he is going to observe? If they are not slipping with respect to wedge, he is observing that this goes with A naught, this goes in this direction with A naught, and wedge is going with A naught. So this you can consider a single system and the whole thing is going with acceleration A naught. So for this to happen, what should be the ratio of m1 and m2, that we need to find out. I hope question is clear. So I can comfortably solve this question standing on the ground. So you be here and observe the motion, you can solve the question. Right now I am talking about non-inertial frame. So I will try to solve this problem being on this frame which is accelerating. So I will place my observer here. So observer is here. So this observer, as he is non-inertial, he is accelerating, he will add pseudo force on this block, that is m1 A naught, pseudo force on this block, that is m2 A naught, right. So now we are observing motion with respect to this frame. So first thing I did, I added pseudo forces, right. Now real forces, string will exert force in this direction T, this will have m1g in downward direction, and then one normal will come from here, contact force, normal on m1, I will call it n1. Similarly for m2 real forces, tension is the real force, this contact on m2, let us call it n2, m2g in downward direction. So now we have complete free body diagram. I can consider any two mutually perpendicular direction for this observer. I can consider this direction, as he is not going to observe any motion of these blocks, because it is given in the question that blocks are not slipping with respect to wedge. Okay, so he is not going to observe any motion of this block and any motion of this block. So any two mutually perpendicular direction you can take. If I take along the incline and perpendicular to incline, so this mg I will resolve along the incline and perpendicular to incline. If I extend this one, this angle is 53. So first I will resolve mg, component of mg perpendicular to incline, m1g cos 53 directly I can write, cos 53 3 by 5. So I am substituting value of cos 53 3 by 5. Similarly it is another component in this direction, mg sin 53, sin 53 is 4 by 5. So I can write m1g 4 by 5, mg I already resolved, so this I will remove. Now you can see that m1 A naught is also making some angle with incline, this angle is 53. So its component in this direction, m1 A naught cos 53, cos 53 is cos 53 3 by 5. So in this direction it will be 3 by 5, and another component will come in this direction, that is m A naught, m1 A naught cos 53 sin 53 4 by 5. Okay, now I will remove this one. I will remove this one, and this is coming cos MA naught M1 A naught cos 53 3 by 5. So we have resolved pseudo as well. So all the forces we have resolved along the plane and perpendicular to the plane. Same thing I am going to do for M2 block. See, M2 block, in this direction component of MG, M2G cos, if this angle is 53, this angle will be 53, right? Cos 53 3 by 5. So this will be 3 by 5. So I resolve the component, and similarly another component 4 M2 G by 5 sin 53. And now let us resolve M2 A naught. If this angle is 53, this angle will be 53. So it will have two components, M2 A naught cos 53, M2 A naught sin 53. So this will be cos 53, and here it will be sin 53. So cos 53 means 3 by 5. So I am directly writing M2 A naught cos 53 is 3 by 5, and this is 4 by 5 times M2 A naught. Now I will remove this. All the forces we have resolved for M2 block. As this observer observes these two blocks at rest, so he will apply Newton's first law in this direction, Newton's first law in this direction for M1. Similarly, he will apply Newton's first law in this direction and in this direction. This direction there is no use, this direction there is no use. So I am not writing the equation for this and this one. If you are interested, you can write that equation. Now let us see what is happening along the incline. So along the incline I can see this T is getting balanced by T is equal to 4 M1 G by 5 plus 3 M1 A naught by 5. Now look at this one. Here T, or I can say 4 M2G downward force, 4 M2G by 5 is equal to T plus 3 M2 A naught by 5. If I add these two equations, TT will get cancelled out, right? We need to find out ratio of M1 and M2, okay? So this side, if I take this term, then I am getting, see, if I substitute G is equal to 10, M2 I can see getting cancelled out. Similarly, M1 after adding M1 will get cancelled out. Here G is equal to 10. So 10 by 5 will give you 2. This is 8. This is given 5. 8 plus 3. So this side I can see 11 after substituting value. I can see 11 M1, and this term will come this side, and then you are going to get here 2 8 minus 3 5 M2. So after simplifying these two, you are getting 5 M2 is equal to 11 M1. That means M1 by M2 is 5 by 11. If the ratio of blocks is 5 by 11, then they will remain stationary. If ratio is more than that, M1 by M2 is greater than 5 by 11, then this will slide this way and this will slide this way with respect to the observer, right? If ratio is less than this one, then this will go in this direction and this will go in this direction, right. So for this particular ratio they will appear stationary. I hope this example is also clear, right. Now, so I have discussed two simple examples so that you can understand how to apply pseudo force when we are on non-inertial frame, okay. So this part is clear. Let's see another example. So go through the question. Solid sphere of mass 2 kg is resting inside a cube. So there is a cube which is accelerating because velocity is changing with time. So you can see that this cube is accelerating. It is having x component and y component. Now it is given that all the surfaces are smooth, sphere is at rest with respect to cube, sphere is not moving with respect to cube. This is the diagram. Question is, what is the total force exerted by the sphere on the cube? How much force is exerted by sphere on the cube, or how much force is exerted by cube on the sphere? Action reaction pair, right. So we have got two options again. I can observe the motion of the ball. So ball will remain at this point, and after some time cube, because it is having x component of acceleration and y component of acceleration, this cube will go to new location and ball will also go to new location, okay. So from ground frame I can see ball is having acceleration in x direction and ball is having acceleration in y direction. So from ground frame I can see ax and I can see ay, right. So I will apply Newton's second law. From ground frame I will apply Newton's second law in x direction and Newton's second law in y direction. What if I want to observe the motion of the ball with respect to the cube? So with respect to the cube, see, so if person is standing inside the cube, so I will place the observer here. So say observer is here. As cube is going with this velocity with respect to ground, let's calculate acceleration. If I differentiate the velocity, I will get the acceleration, right. So 5t I cap, if I differentiate, I will get 5 I cap plus 2 j cap. So in x direction, lift is having acceleration, or this cube is having acceleration 5 meter per second square, and in y direction this is having acceleration 2 meter per second square. As the frame is non-inertial, with respect to this frame, if I want to observe the motion, first thing I need to do is adding pseudo force. So mass of the block is 2 kg, pseudo force is mass of the block, acceleration of the frame, direction opposite. So mass of the block 2, acceleration of the frame, x component if I focus on, then 5 into 2, 10 Newton I can see in this direction, pseudo force. Mass of the ball, acceleration of the frame, direction opposite, 4 Newton I can see in this direction. So pseudo forces we added. After adding these pseudo forces, I am going to observe real forces. So you can see ball is in contact with this vertical wall and ball is in contact with this horizontal surface. So this vertical wall will be exerting force, let's call it Nx, and this horizontal surface will also exert force, let's call it Ny. So Nx, Ny I will observe, and I am going to observe one more force, that is gravitational force. On this 2 kg ball there will be gravitational force 20 Newton. So this box is going this way, it is in vertical plane, so mg will be acting in downward direction. So this is the free body diagram, and this observer is not going to observe any motion because ball is always at corner D. So if ball is at corner D, what he is going to write, for x direction let's write first, nx minus 10 is equal to 0, Newton's first law. In y direction, ny minus 20 plus 4, 24. So from here we have value of nx and ny. Nx is coming 10 and ny is coming 24. We need to find out the force exerted by a sphere on the cube. So in opposite direction, so nx in this direction, this is the force by wall on the cube, force by cube on the ball. Similarly, ny is the force on the ball by the cube. Opposite will be the direction of forces exerted by ball on the cube. Anyway, we need to find out resultant. So net force coming is nx square plus ny square. So substitute the value of n here, you will get the answer. This is first part, right? Now if I add one more part, if ball is initially at corner C and it is released from rest, find time taken by ball to reach corner D. So I added one more part so that you will be having clarity. Okay, so initially ball was released from point C, and then how long will it take for ball to reach to D, that we have to tell. Okay, so if ball is say somewhere here, then obviously this wall is not going to touch the ball. So this nx won't be there in the free body diagram. Remaining all the forces will be as it is. So this force pseudo in y direction, this force pseudo in x direction 10 Newton, ny in upward direction, then on the ball, right now these are the forces along with the weight. So now ball is at new location. For this one, this horizontal component of force will be 10 Newton, and then this is 20 Newton weight. So this is the free body diagram for second situation, right? The person is standing inside, he is observing this. So this is the free body diagram for the person is inside. So he observes that ball goes this way because this is unbalanced force. As soon as ball leaves the contact C, there is no normal coming from this wall. So there is unbalanced force which will drag the ball this side. And in y direction forces will get balanced, ball will always remain on the floor. So this unbalanced force will provide acceleration. So for second part, this is 10 Newton force, mass into relative acceleration. If I say this distance is 10 meter, how much time it is going to take for ball to reach to D? So relative acceleration is coming with respect to this observer. This is unbalanced force. So if you write F is equal to ma, Newton's second law, then whatever acceleration you are going to get, that is the relative acceleration. So A relative is coming 5. A relative is coming 5 meter per second square. If we have relative acceleration, I can apply formula S is equal to S relative is equal to u relative t plus half a relative t square. With respect to lift, it is released, so this quantity will be 0. And if I substitute values here, s relative is, it has to cover relative distance 10, half relative acceleration we got is 5 into t square. If I simplify, then I am getting t is equal to 2 seconds. So after 2 seconds after the release, ball is going to hit corner D. So this part is also clear. So simple problem, we could have observed the motion with respect to ground or with respect to lift. Second part, if you observe the motion with respect to lift, it will be very simple. You will observe that motion is something like this. But when you observe from the ground frame, second part, then you will see ball is going up and ball is also moving this way, right? Instead of ball moving this way, actually you are going to observe that lift is moving in forward direction. So ball remains at its location and the lift just goes like this. So the motion of the ball will be something like, to understand what I am saying, for second part, if I draw the diagram, initially ball is here, right, at this corner, and we are observing the motion of ball with respect to lift. So lift is moving in x direction and y direction, and as soon as it leaves the contact, when lift moves little forward, it loses the contact with this wall. So now no force is coming on the ball in x direction, so ball cannot move in x direction with respect to ground frame. In y direction there will be force coming, normally action and mg resultant will accelerate the ball up. So what happens after some time, that situation is something like this. Ball will only move in y direction, lift will move in x and y direction. So ball will be somewhere here. So person is standing on ground will observe that ball is going in y direction only, but lift is going in x direction and y direction. So ball will go in y direction because of the normal and mg, it will go in y direction. Lift, because of its acceleration, will move forward and upward. So you can see that if I want to observe from ground frame, I have to get the motion of lift with respect to ground frame. So if I focus on lift, lift is having acceleration in this direction, that component is coming 5. So acceleration of lift is 5. So from ground frame, if I want to find out how much time it will take, so lift has to cover 10 meter. Lift has to cover 10 meter. So to cover 10 meter with acceleration 5, how much time it will take? 10 is equal to half, acceleration is 5 into t square. You can see t you are getting 2 seconds. So from ground also if you observe, we are going to get the same result. So inside lift, person is observing that ball goes in x direction. Outside the lift, person is observing that ball is going in y direction. Inside the lift, person is not observing any motion of the lift because he is in the same frame. Outside the lift, that means person is standing on ground, he will observe that lift is having motion in x direction as well as y direction. So from different frame, the motion observed will be different, but when you calculate parameters like time and real forces, they will come same from all the frames, right? So I hope this question is clear. Let's take another example. Look at this one. Here theta is given 37 degree. and this is fixed. Right. So when you release these two blocks, obviously this will slide down and block M will have some acceleration, right? I can easily say that for this observer, the motion of this block will be in this direction. Let's call it block A and this as block B. Okay, so I can see with respect to ground, acceleration of block A will be along the plane in downward direction. Okay, this wedge is fixed. This is fixed. Now for the motion of B, as B is kept over a moving block, accelerating block, if I want to observe the motion of B with respect to this frame, then it might be relatively easy. We don't know, right? The only thing I need to do is, as this is non-inertial frame, I need to add pseudo force. So I'll add pseudo force on this block. Mass of the block, acceleration of the frame. So if I draw free body diagram of block B, then from here one normal reaction will come and on this one mg will be there. So observer on this accelerating frame will observe that due to this component of MAA, block will go this way. So this observer will observe this block goes this way. Person is standing on the ground observes that this is coming down along the plane, right? So what I'll do, I'll observe the motion of A with respect to ground, because this is simple, along the plane it is coming in downward direction, and I'll observe the motion of B from this frame. So let's write equation. Okay, separately if I draw free body diagram, so free body diagram of this block, mg acting downward direction, normal upward, and then a pseudo. If this angle is theta, this angle has to be theta along the plane. This is theta. So I can see two components of this pseudo force. One in this direction, MAA cos theta, and another in this direction, MAA sin theta. So I resolve that force, I got two components. Okay. So let's first write the equation for block B. Now this observer observes that this block is having unbalanced force in this direction, due to which this block will move. And as block always remains in contact with block A, block B remains in contact with block A, he is not going to observe any acceleration in this direction. So he will write one equation for this motion and he will write one equation for this direction. In this direction there is acceleration, so Newton's second law. This direction Newton's second law, and in this direction Newton's first law, right? So first equation is this force MAA cos theta is equal to mass into, what he observes is the acceleration of B relative to A. So you have to be little careful. So acceleration of B with respect to A, we are getting this side, F is equal to MA relative. So real plus pseudo is equal to mass into A relative. First equation I have written for acceleration in this direction, acceleration of B as observed by a person standing on A. For this one I wrote Newton's second law. Now Newton's first law, if you look at y direction, he is not observing any motion. So if he is not observing any motion, I can write n plus MAA sin theta minus mg is equal to 0. Newton's first law. Now block B over. Okay, so in x direction Newton's second law, in y direction Newton's first law, right? For block A, if I draw free body diagram of block A, I can see one reaction coming from here, or I can see if A exert force on B in this direction, B exert force on A in this direction, N. So one normal, one reaction, one mg, any other force, two contact, one field, and as motion of this block we are observing from ground, no pseudo inertial frame, right? Ground frame, inertial frame. So this is the free body diagram he is going to draw, and what he is observing that along the incline it is coming down with acceleration A. So I need to resolve all the forces along the incline and perpendicular to the incline, right? So this is along the incline. If this is along the incline, see mg here in this direction, this angle is theta, mg cos theta, mg sin theta. So in this direction mg cos theta, in this direction mg cos theta, and in this direction mg sin theta. Now mg I remove. Similarly, normal you can see, normal is acting vertically downward. So again it will be having two component, one along the plane, that is n sin theta, and in this direction n cos theta. I resolved n. So if you just look at along the plane what is happening, I can see n sin theta and mg sin theta will accelerate the block in downward direction. So for that I can write another equation, n n sin theta plus mg sin theta is equal to mass into acceleration. N sin theta plus mg sin theta is equal to mass into acceleration. We are getting AA. So these are the three equations, these two for block B and this one for block A. I hope up to this point everything is clear. Now I'll solve these equation here. Free body diagram is clear. I'll remove this one. So I hope up to this point you understood each and everything. Let's solve these equations. Okay, so if I want to find out AA and I multiply this equation to sin theta, this equation already we have n sin theta. If I subtract these two, so subtracting these two, if I multiply this whole equation to sin theta, so this whole equation I'll multiply to sin theta, and then I'll subtract this equation from this equation. So here minus will come, here minus will come. Let's see what we are getting. So this n sin theta and this n sin theta will get cancelled out, right? And see what we have. So I can see m a sin square theta first term and then minus mg sin theta. Okay, this over, now we have this side, we have minus mg sin theta, another term, one more minus mg sin theta. On other side I can see MAA. So MAA. Let's simplify. So MAA we have here and MAA here. Okay, let me check calculation. Okay, so this is mg sin theta. Okay, mg sin theta 2 times mg sin theta, and this is 1 minus okay, this is coming with minus sign. I forgot to place minus over here. Let's write this with minus sign. Minus m a. Okay, so get this term this side. So I can see 1 plus sin square theta MAA, and these two term on other side, that is 2 mg sin theta. MM will get cancel out and we have acceleration of A with respect to ground, that is 2g sin theta divided by 1 plus sin square theta. If I have the acceleration of A, then I can find acceleration of B with respect to ground. Look at this one. If here I substitute M A is 2g sin theta cos theta divided by 1 plus sin square theta. I substitute this value here, and M acceleration of B with respect to A. M getting cancelled out. Do remember that whatever we got here, that is acceleration of B with respect to A. In that I need to add acceleration of A with respect to ground, then I will get acceleration of B with respect to ground. What I am saying, you are asked to find out the acceleration of the blocks with respect to ground, right? You got this value, which is acceleration of B with respect to A, relative acceleration with respect to A you got, but you need to find out acceleration of B with respect to ground. So to get acceleration of B with respect to ground, look at this one. Acceleration of B with respect to ground is acceleration of B with respect to A plus acceleration of A with respect to ground. I can use this relative acceleration formula to calculate B with respect to ground. So this I'll write vectorially, this I'll write vectorially, and then I'll get the acceleration of block B with respect to ground. So this is what, when I solve half problem standing on the ground and remaining half problem is standing on the block A which is accelerating. So half problem, our frame was inertial, because from ground I can easily see the motion of this block sliding down the plane, right? Remaining half, as I can easily observe the motion of B, then motion of B as observed from A can only be in this direction, this way, right? So as the component of pseudo is coming in this direction, the block will slide backward as observed by person A. Okay. Now if I want to solve whole problem standing on the ground, I'll be here and I'll write the equation for block A and block B standing on the ground. Let's see whether we are getting same result or not. So this is the result we are getting. So somewhere here I'll write the result. AA we are getting 2g sin theta divided by 1 plus sine square theta. Okay, this is the result we got by this method. Now, so this calculation now I will remove. As I am observing motion of A with respect to ground, previous case also I observed the motion of A with respect to ground, this equation is not going to change. I am now observing motion of B with respect to ground, so these equation will get changed. These equation will get changed because that was the motion of B as observed by person standing on A. Now, as our observer is on ground, see, so I will remove all this. As our observer is on the ground, there is no need of pseudo. So, this observer observes that on B there are only two forces acting, one normal upward direction, mg in downward direction. So, as there are forces only in vertical direction, block B can accelerate only in y direction. So, acceleration of B with respect to ground, let us call it AB, acceleration of B with respect to ground in downward direction with respect to ground, acceleration of A with respect to ground along the plane, for that I already wrote equation. So, for B now I have to write equation. So, look at the free body diagram, normal upward, mg downward. So, what this person is going to write, that mg minus n is equal to mass into acceleration of B, simple, right. If I just focus on this equation and this equation, now this is the equation for B. Number of unknown we are getting is normal, acceleration of B with respect to ground and acceleration of A with respect to ground. So, there are three unknowns and maximum I can make two equations. Now, there is no use of all these equations because our frame is inertial. I require one more equation. So, apart from these two equations, we require one more equation. What should be the equation? Previous case, there were three unknown, we got three equations, two equations for the motion of B, one equation for motion of A. When we are observing from the ground, we are getting one equation for A along the incline and one equation for the motion of B. One more equation is needed. I can use constraint. So, I will remove all the forces. Now, let us talk about constraint. Rigid body constraint. If this block is in contact with this block, that means along common normal they must have same velocity. So, I will equate velocity along common normal and differentiating that will give me acceleration, right. So, along common normal. So, look at this surface, along common normal means this direction. This direction, this is common normal for this surface. For this surface, this is common normal. And if you focus on block A is having velocity acceleration this way. So, A is making some angle along with common normal. I will resolve the acceleration along common normal and equate it. So, if this angle is theta, then this angle will be 90 minus theta. This angle is 90 minus theta. So along common normal, if I see, B is already having acceleration along common normal. Acceleration of B is in this direction. Acceleration of A in this direction is, if I resolve this acceleration in this direction, then I am getting acceleration of A cos 90 minus theta. Cos 90 minus theta is sin theta. So along common normal, I can write equation acceleration of B will be equal to acceleration of A sin theta. So this is third equation which is coming from constraint. So now first, second and third, we can solve these three equations. We can check whether we are getting same answer or not. So let's simplify. So if I substitute this value here, then I can see mg minus n is equal to m, AB is AA sin theta, and here if I don't want n, I will multiply this equation to sin theta. So this equation I will multiply to sin theta, okay, and I will add these two equations. So see, this n sin theta, after multiplying sin theta here, this will get cancelled out, and then this side I am getting mg sin theta. This sin theta is multiplied to the whole equation, mg sin theta this side, and then here we have minus mg sin theta, and this we are adding, not subtracting, right, because this is already with minus sign. So I will remove all these minus because they are creating confusion. So another term we are getting is this mg sin theta plus mg sin theta, and if you see on other side we have maa sin square theta plus maa. So look at this equation. This side I am getting 2 mg sin theta, and other side I am getting 1 plus sin square theta, that I can bring down. So A is coming 2g sin theta divided by 1 plus sin square theta. Look at this result, they are same. So first I solved one part standing on the ground, second part standing on the wedge, and what I am trying to say is, irrespective of the frame you are selecting, the answer you are going to get will remain same. So whether I calculate acceleration by first method or I calculate acceleration by second method, I am going to get the same result, right. So in this chapter we learn what we are supposed to do when we make our frame non-inertial or we switch to non-inertial frame, then how to solve the problem. So I hope a complete concept is clear, right. So in next class we will start new topic, that is friction. So I hope you enjoyed today's class. Thanks very much for watching.